Alright, given that we have an electric force, say on charge 1 on charge 2, we know from the Coulomb law that we previously worked out, derived, etc., that it's the product of both charges, and then you have to divide out the square of the distance between them. Now, in order to make this a vector equation, which it technically is, we need to add this pointer, because everything that you see here in yellow, this is a magnitude. And then that unit vector, a magnitude times a direction, gives you the vector, which in this case is a force vector. Now, if we want to know the force per unit charge, so say the force on charge 1 per unit charge 1, then that means we would divide out our charge 1. So I'm simplifying the notations just a little bit for the sake of discussion here. And this boils down to just kq2 per r squared. And we define that to be the field strength of charge 2. Now, a field strength is always, okay, the force per unit quantity that interacts in the field. That is a oversimplified way to put it, but sufficient for our purposes. And so we can kind of rewrite things a little bit here. So the electric field of charge 2 will be realized that way, and we could write the force on charge 1 is going to be the product of that charge and the field that influences it. And so this has a nice parallel with, so we're going to write out Newton's second law here and just think a little bit about the parallels between these two things. So charge and mass, how those correspond to one another, and really the way to really understand that would be to think about the fact that I have an electric field strength and I have a gravitational field strength. Now, that's going to be true when A equals G you're dealing with gravitational field strength. And we're so used to Newton's second law being F equals ma, which is an effective computational tool, but doesn't tell you the story from a field effect standpoint that is helpful in understanding the parallels between these two things. So the structure of Coulomb's law and Newton's law of gravity are essentially the same, except one deals with charge, the other with mass. And then these force equations that are in terms of a field factor are saying the same story, but about two different kinds of fields, and therefore two different kinds of field effects. And so it's worth saying that there's a parallel, and then that's good enough.